All right, we're going to be looking at properties of logarithms. Key concept. The logarithm of a product is the sum of the logarithms of its factors. So let's take a look at what does that mean. So for example, log base b of m times n, these would be the two factors, m times n, okay, is going to be the sum of the logs of each factor. Notice the base stays the same. So if I have, let's look at an example, log base b of 20 is going to be the log base b, okay, whatever number that is, and let's think of two factors of 20, 5 plus log base b of 4. So you can take a number and break it down into its factors. Okay, 5 times 4 is equal to 20. Let's look at another example. Log base. All right, let me get on the right page here. Here we have the log base 2 of 6 times 2. It's already broken down into its factors, so we can split this up. Log base 2, base stays the same, of 6, the first factor, plus log base 2 of 2. Okay. So let's look at an example on how we might use this to solve an actual problem. Okay, so trying to get used to this new laptop, moving around from one screen to another, so bear with me. So how would we handle this? Well, we're trying to solve for x. So we're trying to think of, remember, when we're going this direction, if we're going from plus, okay, if we're going from plus over here to multiply, we have to take the two arguments, m and n, and multiply them together to get this. So what I'm going to do right now is I'm going to combine these two into one using this property. So again, what do we do with m and m to get to go to 1? We multiply them. So we're going to have log base 6, the bases have to be the same or this will not work. Okay, and multiplying x times 9, we get 9x. Now, at this point, when solving this equation, since log base 6 and log base 6 are the same, just like with exponents, we can cancel them out. We get 9x equals 54, so x equals 6. And that's how we solve that type of problem. Okay? Quotient property. Make sure you're writing this down. Quotient means division, the answer to a division problem. So we have log base b of m divided by n. Okay, so notice that we're dividing. So what happens to our logs? That's right, subtraction. Remember up here we were multiplying. So what happens to our logs? We're adding. Remember, very important, a logarithm is an exponent. Okay, if you remember that, when multiplying like bases, you add the exponents. Okay, when dividing, Okay, like bases, the bases are going to be the same for both of them. When dividing, you subtract. Same rules as exponents. Okay, so let's take a look at an example here. Okay, so we have log base b of 10 over 2. So we're going to do log base b of 10 minus log base b of 2. Now we can go the other direction too. If we have a subtraction, we can take the two arguments and set it up like this. So we can go this direction to 1, or we can break it into 2. So let's look at an equation where we need to solve. Wrong page. Okay, so let's look at this example. We have log base 8 of 48 minus log base 8 of w equals log base 8 of 4. Okay, remember, when you look at this, what you're looking for is the operation. That's going to tell you, since it's subtraction, we are going to divide the arguments. So when solving this, bases are the same. Log base 8, we're dividing the arguments, so 48 on top, first number on top, w on the bottom, that's going to be equal to log base 8 of 4. Okay, since the bases are the same, we can cancel them. So we get 48 over w is equal to 4. Now we want to solve for w, so we're going to have 48 is equal to 4. Excuse me, equal to 4. So cross multiplying, we get 4w equals 48. Dividing by 4, we get what w is equal to 12. Makes sense. 48 divided by 12 is 4. Alright, next property, power property. Here we have log base b of m to the p power. I really like this property. I'm not sure why, but it's interesting. Since what we have here is an exponent, our log is the exponent, right? And it's raised to an exponent. Remember the rule, when you have an exponent raised to an exponent, that's right, you multiply. So the p comes down in front and multiplies times the log base b of m. So for example, if I have log base b of 4 to the third power, we have an exponent raised to an exponent, so we multiply. So the 3 comes down in front, so 3 times log base b to the 4th. And it can go vice versa, it can go back up on top. So you could bring the exponent down front, or you could take that down, whatever is being multiplied, you can bring that back up on top, depending on what you need. So let's look at an example of where we have to solve. Okay, so looking at this problem, notice the bases are both 10, base 10, that's important, bases have to be the same. Now, what you need to start recognizing is when you see this multiplication here, notice the number is down front. So, when it's down front, usually when you're solving, you want to bring it back up on top. So we're going to have log of 27 equals log of x to the third. So I took that power out front and I moved it on top. So the 3 moves on top of the x because it's multiplication. So now that our bases are the same, we can cancel those out. We get 27 is equal to x cubed. Okay, and so we're looking for, well, what number to the third power is equal to 27? That's pretty obvious that that's going to be 3. But if you didn't know that, maybe you'd want to ask yourself the question, what number to the third power is 27? Well, 3 to the third power is 27. So what number does x need to be in order for this to be equal? X needs to be 3. X equals 3. So now I want to take a moment. On your video notes that we did last class, there was one problem that I skipped. So let's take a look at it. 3 to the x equals 7. Remember I said we'd come back to that? Well, let's take a look at that. I'm going to do it on this page though. I zoomed in too far. Oops, wrong way. Wrong way. So we have 3 to the x equals 7. Okay? Well, we can't make the bases the same here. So what we want to do here is we want to take the log of both sides. So we're going to have the log of 3 to the x equals the log of 7. Okay? And notice we have an exponent raised to an exponent. So we're going to use the power property. When we have an exponent raised to an exponent, that exponent on top, going to bring that down front. So bases are the same. So if you bring that exponent down front, x times the log of 3 equals the log of 7. We want to solve for x, so we're going to divide both sides by the log of 3. Yes, you would need a calculator to do this problem. Thankfully, we're at base 10, and you can just plug it in your calculator. So log of 7 divided by the log of 3. I don't know how well you can see this, but there's a log button over here, down here, right here, next to 7. So the log, what's that? Log of 7 divided by log of 3. Try and get out of the way here. So the log of 7, sorry it's not easy to see. Close the parentheses on the 7, divided by log 3. Okay, so we got 1.7712. Approximately as our answer. And that's how you would solve that problem on your notes. We'll be doing more of those later. Have a good night. See you tomorrow.